Hello everyone, welcome back. Welcome to the fifth episode of the series. In this episode, we'll again discuss a very interesting set of uh, LRDI questions from the previous CAT papers. Fine. So we have done this particular discussion 4 times before this episode. So if you want, you can go and watch these last 4 episodes. Small announcement. I have done this announcement a couple of times as well. So R4 batch we are launching. The batch launch date is 22nd February. Okay, and in that batch I'll be taking LRDI classes. My name is Swapanil. Apurv sir will take Quant classes, and VARC classes will be taken by Ayush sir and KD sir. Okay, so this is a complete English medium batch. If you feel that Hindi medium is not batch is not going to be very comfortable for me, this is the batch you can definitely join. Okay, so let's start with the discussion. The set I have is a very interesting one. It's from CAT 2017 slot 1. Simple happiness index of a country is computed on the basis of the 3 parameters: social support, freedom of life choices, and corruption perception. Okay. This is S, F, and C in short. Each of these 3 parameters is measured on a scale of 0 to 8 integers only. That means 0, 1, 2, 3, 4, 5, 6, 7, 8. A country is then categorized based on the total score obtained by summing up the scores of all the 3 parameters as shown in the following table. So if some country is scoring, between 9 and 13, including both, that is termed as neutral country. If some countries is scoring 20 to 24, that is termed as a very happy country, something like this. Okay. The following diagram depicts the frequency distribution of the scores in S, F, and C of 10 countries: A, B, C, D, E, V, W, X, Y, and Z. Okay. So let's first of all understand the diagram, what the diagram is telling us. If I want to get the better idea, I'll just make a table out of it: S, F, and C. Okay. And if I look at the point 1, some points are given. Point 1 is given to twice. Point 1 is given twice when it comes to F. Okay. Point 1 is not given not given any times in S. If I look at parameter S, we don't have 1 point here. If I look at parameter F, we have 1 how many times? 2 times. If I look at parameter C, we have 1 how many times? 1 times. Okay. If I look at point 2, and if I look at point 2, S, if I look at parameter S, 1 point is not given to any country, so this is nothing. Okay, and 2 points are given to only 1 country in F parameter, and C is having frequency of 0.2, which is 3. Okay, if I look at point 3 also, just to give you the better idea, if I look at 3 in S, 3 times 3 is given. 3 times 3 is given. So frequency of 3 in S is going to be 3. Perfect. This is 3. Frequency of 2 in F is going to be 2. And frequency of 3, frequency of 3 in C is going to be 4. Okay, I'll just quickly repeat. Frequency of 3 in S is going to be 3. Frequency of 3 in F is going to be 2. Frequency of 3 in C is going to be 4. That's what we have to do. Okay. So these are the kind of points we are given. We have to assign the points as per the data given. What is the data given? Let's read the data also. A and C jointly have the lowest score of 7 with the identical score in all the 3 parameters. Z has a total score of 17. All the 3 countries which categorized as happy have highest score in exactly 1 parameter. So first of all, we have to make a table out of it to get the better idea. Okay, I cannot just look at this graph and try to get the idea about the numbers. It's going to be slightly confusing. So let's make a table out of it. Okay, this is the data primarily, and I'm going to make a table. Point number 1, point 2, point 3. 4, 5, 6, and 7. This is the parameters we have. Parameters are S, F, and C. And we know if you look at score 1, one is given twice in F and 1 here. We are not getting any score 0. So this is starting from 1 to 7. So we don't have to write 0 to 8. Although it was mentioned points are given from 0 to 8. But we are not able to identify any country which is getting 8 points or giving 8 points in any parameter. So I'll make the table according to the data given 1 to 7. Okay. If I look at 2, so F, there is 1, 2, C, there are 3 times 2. Okay, score of 2 in S is 0, score of 2 in F is once, score of 2 in C is thrice, score of 3 in S is thrice. Okay, here it is 2, then 4, score of 4, this is thrice, score of 4, here it is once, and here it is once. Okay, what else? Score 5 twice, F it is thrice, and there is no score of 5 in C, and score of 6 1 and 1, there is no score of 6 in parameter F. Okay, score 7 1 and 1, there is no score of 7 in parameter C. Okay, this is the only part which is slightly confusing. We have to make a table out of it to get the better idea. Otherwise questions, we can solve, but we'll not be having a clarity. Eventually we have to make a table because this is more, visual friendly as far as I am concerned rather than this graph. Okay, so as per the first point, A and C jointly have a lowest score, which is 7. Okay, so A and C, they have 7 score. The total score for them is 7. What else? With identical score in all the 3 parameters, S, F, and C. So we'll try to make 7 by using these frequencies. Let's understand how do we do it. What is the maximum number I can use to make 7? Can I score 700? Not possible. So this is what we have to do in this case. Can I say 610 is possible? 610. Nobody is giving 0 point, or getting any 0 point. So let's forget about this combination. Also 610 is not possible. Can I make 511? Okay, let's understand 511 is feasible or not. Because I want 511 twice. So if I look at this 5, if I want to use twice, there should be frequency of 5, which is 2 times, and we have in this particular case here. Okay, this is 5 used 2 times. I want 1 2 times. Do I have 1 2 times? Yes, 1 2 times I have here, but in the same case, which is not possible. Okay, if you look at this, 5 is already given to us. I'll just alter these numbers. If I want to use 511, and 511. So I need to have 5 twice because A and C both are going to get 5 in the same category. Okay. So where do we have 5 twice? If I have 5 twice here, I can write 5. Now there are 2 times 1 here. That's perfectly alright. Okay. But we don't have 2 times 1 here. So here I can use 1 times, and I don't have 1 other time. So that is not possible. If I start writing 5 here, because frequency of 5 is here twice, you can see that the number is 3. So I can use 5 exactly 2 times. Okay, that is not a problem. Now I want to make 2 times 1 here, 2 times 1 here. So do I have 1 here? I don't have 1 here. So I cannot make 1 here. I cannot make 1 here because we have only 1 here. So this is practically not possible. So this entire combination is not possible. I cannot give 511 to make 7. I hope you got the idea. And this is actually the gist of this question. This is what we have to do in this question. We have to assign frequency as per the availability. Okay, fine. So 511 is not possible. Can I make 421? Can I make 421? Okay, 0 I cannot use. 0 is not given to any of the countries. So 0 I will not be using. 421. Okay, that means I need to use 4 how many times? 2 times. And 2 how many times? 2 times. And 1 how many times? 2 times. Okay, 1 we have 2 times 1, and that is only in F parameter. So I'll write 1 here twice. This is done. 2 I have 2 times. Where do we have 2 times? C. So I can write 2 times here. Perfect. This is done. And 4, if I want to write 4 2 times, I have 4 2 times. Yes, I can write 4 2 times. Okay. So that is frequency and S assignment we have to. This case is feasible. That is not a problem. Okay. Is there any other chance of making 7? Let's see. We'll try to make 7. If I say this is 3 3 1. Okay. So we have to use 3 3 1. Now let's understand 1 is twice available and only in F parameter. So I'll write 1 here 2 times. Just wait for a second. I need a little space. So this is 3, 3 and 1. Okay. So if I want to use 1 2 times, I have 1 2 times here. Okay. 3 I have 2 times in S. Yes, it is more than 2 times in fact. So I can write 3 2 times here. And frequency of 3 in C is also 4 times. So I can write 3 here. Okay. So this is again a possible scenario for A and C. The total score being 7. The order is fixed because the summation is 7 and the frequency availability. Okay. I cannot say 3 3 1 because we don't have 2 times 1 in parameter C. That's what we have to understand. Okay. Fine. I don't have 0, so I cannot make 0. Either I can make 3 1 3 or sorry 3 3 1 I can use, or you can use 4 2 1. I cannot use 5 because if you use 5, it's practically not possible to make this combination. I have just discussed it. Okay. Can I say this is 3 2 2? One more possibility here, 3 2 2. Fine. Let's see whether we can make it 3 2 2 or not. 2 2 times. Do we have 2 2 times here? No. We don't have 2 2 times here. We don't have 2 2 times here. We have more than 2 times only in C. So this is fulfilling, but this is practically not possible. Okay. We don't have 2 times or more than 2 times in two parameters. We have frequency of 2 more than 2 in only C. We have only 1 times of 2. Okay. So we cannot make this. So this is settled. Now we have 2 options for A and C. Right. So this is what we are supposed to do with these questions. Understood? Chalo. Let's move ahead then. Point number 1 is done. Z has total score of 17. Okay, Z has a total score of 17. That means I would like to make Z score. It is in S, F, and C. Okay. Now, how do I make 17? First of all, let's understand what kind of country Z is. Z is a happy country. Okay, between 14 and 19, country is considered to be a happy country. So Z is a happy country. Its score should be 17. And from the third point, it is mentioned there are 3 countries happy. All the 3 countries. That means there are only 3 countries which are happy. Are categorized happy. There's all the 3 countries which are categorized happy have the highest score in exactly one parameter. So that means if I look at this, 3 countries which are happy. No, we have 3 countries which are happy. First of all, which country? Let's say X, Y, and Z. 3 countries are happy. Okay, just for the sake of understanding. Okay, and if I look at the parameter S, the highest score is 7. So if I am assigning 7 to this country from S, F, and C, fine. I cannot assign the highest parameter of highest frequency of the other parameter to X again, because I have already assigned 7 of S to this country. I cannot assign 7 of F to this country. Only one parameter will be such as per the statement, which are categorized as happy, have highest score in exactly per parameter. So if I assign highest score of S, which is 7 to country X, I cannot assign highest score F, which is 7 to country X again. Okay, so this has to be assigned to the different country. Okay, so parameter F has a high score of 7, which will be assigned to a different country among the 3 happy countries. And highest score of parameter C is what? 6. This will be assigned to a different country. So that's what it means from the point number 3. That's what we have to consider. Okay, 3 highest score will be assigned to 3 different countries which are considered happy or which are categorized as happy. Okay, so what I need to understand is from this particular point, either Zuma is going to get highest score of 7 here. Okay, fine with this. Either Zuma is going to get highest score of 7 here, or Zuma is going to get highest score of 6 here. Either Zuma is the country which is getting highest score of S, or highest score of F, or highest score of C. Okay, if highest score here is obtained, Zuma will not get highest score anywhere else. Okay, if Zuma is getting highest score in F, Zuma will not get highest score of any other category. If Zuma is getting highest score of C, Zuma will not get highest score of any other parameter. I hope you get the point. This is what the third point means. How do I make 17 in that case? Let's understand how do I make 17. Okay. If 7 is there, I cannot assign 7 here. Fine. If I assign 5 here, 7 plus 5 is 12. 7 plus 5 is 12. Plus 5 is 17. Not possible. Why? Because 2 times 5, I don't have 5 in C. Okay. I have only 5 in F. I don't have 5 in C. I have 5 in S, but we have already used 7 from S. So I have to assign 5 of F and I don't have 5 from C. So that's why it is not possible. Okay. So if I'm not using 5 here, if I use 5 here, this is 5, practically not possible because we don't have 5 here. That's why. So if I make something apart from 5 here, if I say this is 5, if I say this is 4, okay, 7 plus 4, 11 plus 16, again not possible because highest score of parameter C is again given to Zuma, which is practically not possible. So this is again not possible. So 7, 4, 6 is not possible. Fine. Because Zuma is getting highest score of 2 parameters, which is practically not possible. Okay. So what we are going to do here is, if I say this is 7, and if I want to make 17, that is practically not possible because if you look at this, 5 is not possible here. If I 6 plus 6 is not possible because I cannot write 6 here. Okay. And I cannot write 7 here. If I write 4 here, okay, and this is 6, not possible. If I write 3 here, I have to write 7 here. We don't have 7 here. So practically this combination is not possible. So writing 7 here is not working out. So this combination is completely ruled out. Okay. Fine with this? If I assign highest frequency of parameter F to Zuma, then what I'm going to have, 7 is here. And if I want to make 17, so I can 6 here, 7, 6 plus 13, 7, 6 is 13. And I want 4, so I have 4 here, that's practically possible. Okay. Fine with this? If I say 7 and this is 5, 7 plus 5 is 12, this is 5, not possible because we don't have 5 here. Okay, we don't have 5 here. If I want to make like this is 7, okay, and this is 5, 7 plus 5 is 12, and if I want to make 5 here, we don't have 5 here, so that is again not possible. Am I right? If I want to make like this 7, 4 and 6, that is practically not possible because highest frequency or highest score of C is already assigned to other country apart from Zuma because 3 different countries will have 3 different highest scores in each category. Okay, that's what we have understood already. So that means if I write 7 here, there is the only possibility I'm going to get. Okay, I'll just erase this possibility which is absolutely not feasible. Fine. If I say Zuma is scoring highest score of the third parameter, which is C, and that highest score is 6. Okay, this is the highest score of this parameter. Highest score of the first parameter is not giving us any feasible combination. Okay, so 6 here. I know I want to make 17. Can I use 7 here? No, I cannot use 7 here. Can I use 5 here? Let me check if it is 5 possible or not. 6 plus 5 is 11. I want to make 17. I can use 5 here. 11 plus 6, 17. I'm sorry. 6, 5 and 6 will be okay. Okay. So we are not using the highest score of any other category. That is practically possible. Fine. I don't have 6 here. So I cannot make any other combination out of it. So it has to be 6, 5 and 6. Fine with this? 6, 7 I cannot do because 7 is already taken. So for Zuma, the score to be 17, and that is possible in 2 cases. Case 1, when S, F, C score are 6, 5 and 6 respectively. And case 2, when S, F, C score are 6, 7 and 4 respectively. So Zuma can have highest score of either F or C. Zuma cannot have the highest score of S. Fine with this? So this is the maximum I can generate out of it. Let's take this data to the question slide and try to answer the questions one by one. So I have copied the data. Let's answer the questions. Question number 1. What is A score in F? If I look at the previous arrangement, A's score in F. A's score in F is 4. A's score in F. This is 1. In fact, A's score in F. This is 1. And this is 1. In both the cases, whether you consider the first case or second case, A's score in F is going to be 1. Okay. So without any problem, I can answer the question. Answer is 1. What is Z score and S? Z score and S, in both the cases, if you look at the case 1 or case 2, Z score and S is turning out to be 6. In both the cases, the score of Z is 6. Right? So once you get the idea about the arrangement of the frequency and the possibility, it's very simple to answer the questions. Am I right? So question number 3 then. B and D, two countries categorized as happy. I know Z is happy. I have two countries categorized as happy. Which countries? B and D. These are two other countries which are categorized as happy and tied with the same total score, not independent score. Total score is same. What is the maximum score they can have? A very interesting question. Look at the choices we have in our hands. I have already assigned 6, 5, 6 and 6, 7, 4 in these two cases. Okay. If I want to make, see, this is B or D, it doesn't matter which country is B, which country is D. I can make two scores in both the scenarios. Okay. So I want to maximize the score. Score of Z is already 17. And if I want to maximize the score, I have to, reach to the point which I used in the previous statement as well. All the three countries which are categorized as happy have highest score in exactly one parameter. Okay. So what does it mean? If I have given highest score of parameter C to Z, I have to give highest score of F to one of these two countries and highest score of parameter S to one of these two countries. Okay. So if I assign 7 here, fine, highest score here is 7. If I ask, then we have to assign highest score of S to other country, which is 7. Okay. Similarly, in this case, highest score of 7 has already been taken. So highest score of S, which is 7, that has to be assigned to B or D. Okay, 7 here I can assign, that is for sure. Highest score of parameter S. I'm circling this highest score. So highest score of parameter S is taken, highest score of parameter F is taken, highest score of parameter C has to be here, which is 6. Okay. So three different countries should have three different highest scores from three different parameters. Fine, this is what we have. Now I want to maximize the score. If I look at the scores availability, I have used this 7. Yes, I have used this 7, I have used this 6. If I want to maximize the score in this particular scenario, I have used 6 also. This 6 is being used. I have used both the 6s. This 6 is already being used, 6, 5 and 6. Okay. I have used one of the 5s also. So I'm left with 2 5s. Yes. Is this in this particular case I'm talking about? If I look at the points I've already assigned, the points which I've already assigned are like this. I have given 7 to one of those two countries, B and D. Fine. I have given 7 of this parameter also. I have already assigned 6 of this parameter C also. I have already assigned 6 from this parameter. I have already assigned 5 from this parameter. So I'll be left with 2 5s. This is what we have to do. We have to keep that in mind, whatever the frequency is already being used. Okay. Now, I want to maximize the score. How do I maximize the score? I'll write points which are maximum available points. Okay. So if I say 2 times 5 is available here, so I would like to write 5 here. So 7 and 5 is 12. Okay. What is the highest point available in C? 7 plus 5 is 12. I can write maximum 4 here. Okay. So 7 plus 5, 12 plus 4, 16. Fine. So as per this particular scenario, I have used 5. I have used 5 here. I have used 4 here. Okay. So I'm just crossing it. Fine. Now, if I want to use the maximum point available here, what is the maximum point available? I have 2 times of 5 left. So I can write 5 one more time here. Okay. I am not left with 6. I don't have 5 here. I am not left with 4. So I have to assign 3 ones here. Okay. The frequency 3 is very high. We don't have to bother about it, that how many times 3 is being used. If I look at this, 3 is used maximum twice here, maximum twice here. And the frequency of 3 is 4 here and 4 here. So we are left with 3, sufficient number of 3s. We don't have to bother about it. So in this particular scenario, if I look at the maximum score in this particular scenario, यहाँ पर 5 plus 7 is 12 plus 4 is 16. Maximum score. Here the maximum score is 7 plus 5 is 12 plus 3 is 15. Okay. And this is 17. Now this can never be 16. The maximum score of one of the countries Zuma is given, it's maximum, not the maximum, the exact score of Zuma is given. and I know the maximum score of B or D one of those two countries can be 16, other country will definitely have to settle with 15. I cannot make 15 16 because I have already utilized the maximum numbers. I have to make 16, I have to convert 16 to 15. How do I convert 16 to 15? We have multiple options. Okay. If I want to write, I can write 3 in place of 4, so that will become 15. Am I right or not? Practically possible. Okay. So this is what we have to do. I mean, if I look at the cases, we have to identify what is the maximum frequency I can assign of a particular number in a particular parameter, so then the score is maximized. So here the maximum score for both the countries is same as per the question, that can be 15 only. Okay, both of them cannot have 16, both of them can definitely have 15. Okay, if I look at the second case also, 7 is already being taken. So what I have done here, I just use the data again. Look at this. This 6 is being taken already. Okay, 7 is taken. This 4 is taken in this particular scenario. 7, 6, 13 plus 4, 70. That's perfectly all right. Yes or no? Zuma, 6, 7, 4 is a score which is 17 only be assigned. Okay. Now, if I assign 7 here, this 7 is taken. If I assign 6 here, this 6 is taken. Okay. Now, remaining numbers I have to assign as per the requirement of the question. Fine. Let's see what we can do with this. I want to maximize the score. What I'm left with. I have not used 5, so I'll definitely assign 5 here. Once. We can assign only one time 5. Okay. And 4 I'm not left with, so I cannot use 4 here. I have to use 3. If you look at this, 7 plus 5 is 12 plus 3 is 15. The score is 15 I'm obtaining here. This score is 17. Okay. Fine. The third country which I'm left with is B or D, one of these two countries. I'm not specifying the order because no need of order in this particular question. Can I make 15 or more than this? I mean, this is 15. It can be either 15 or less than 15 because I have to have the same score. Okay. So I won't like to make it 16. No, because I don't have to make a different score. I have to make a same score. Okay. So let's just understand 6 has already been taken care of. 5 I've already taken from here once. So I'm left with 2 times of 5. I can take 5, 1 5 from here. 6 plus 5 is 11. Okay. I can take 4 here. Okay. I can take 5 here also. But that will make it 5 plus 5, 10 plus 6 is 16. But I want same score. So this is never going to be 16. To make same score, I have to make it 15 only. I hope it is okay. So if this is 15, how do I make 15 here? This is 6. This is 6. This is 5. Okay. Let's say this is 5. 6 plus 5, 11. I can say 4. That is 15. Perfectly all right. I can make 15 in numerous number of ways, but maximum score of both the countries can be 15. So answer to question number 3 is B, Bombay, 15. Okay. Fine. Let's move to the last question of this particular set. If Benga scores 16 and Delma score 15. Okay. So let's understand the cases. I have to assign 16 and 15 here. So if B is 16, okay, B is 16. So B is this country and D is this country. Okay. So let's just write these numbers. Okay. And I have to have score 16 somewhere. So I can make it 16. So if this is, let's say, D and this is B, this is the maximum score I can get in this particular scenario, 7, 5 and 3. Okay. I have to make 16. So if I make 16 here, how do I make 16? It's very simple to make 16. This is 6 fixed, this is 5 and I can take 5 here also. If I take 5 here, it will become 16. Okay. So these are the numbers I am going to use. Now what is the question telling us? That what is the maximum number of countries with the score of 13? Okay. Now let's understand what are the frequency I have used here. Okay. If I look at the numbers, highest scores are taken care of. Okay. And I want to make 13. How do I make 13? Let's understand. 13. Okay. Can I say if I use 4 times 4, I cannot make 13. So I have to use numbers which are more than 4. Okay. and highest score has already been taken care of. Don't have 6, I don't have 7. So the only score which is more than 4 I can take is 5. So I have to use 5 to make 13. I'll tell you one more time what I'm doing here. If I say 4, 4 and 4, that will not be sufficient to make 13. So I have to score at least 1 point where score of more than 4 I'm going to take. So this is what I'm going to do here first. Can I score 6? No, 6 is not available. Can I get 7? 7 is not available. Already been assigned here. Okay, as per the question. Fine. So we have to use 5. Maximum number of times if I want to use 5, that is possible. Not a problem. 4, 4, 5 I can use to make 13. I can say 5, 5 and 3, that can be 13. I'm not left with 6 and 7. So these are the two possibilities to make 13. Okay, there is no other chance of making 13. Now if I look at this 5, 4, 4, 5 I have sufficient number. If I look at this 5, we can use this 5. We have used 5 exactly once here, so I am left with 5. Yes or no? 5, 4 I am not left with, because if you look at this here, we don't have 5. Let's understand what I am going to do. S, F, C. 5, 4, 4 combination I am going to use. Fine. If I look at this, we have 1, 5 here. I can use 5 here. Yes or no? It's in this particular case, already 1, 5 is used here. Okay. So I can use 5 here. Yes. And if I look at 4, 4 is used here. In both the cases, I have used 4 of C. So I'm not left with 4 here. It's a very important point. Understand. In C, I cannot use 4. Why? Because 4 is used whether you consider this case or this case. If you look at this, we have used 4 here and we have used 4 here. So I'm not left with 4 of C. Okay. And I'm left with 5s only in S and F. If you use 5 here, I cannot use 4 here. Okay. That's what we have to do. And if I want to make combination 5, 4, 4, that is practically not possible. Okay. Fine with this. If I use 5 here, I want to make 4, 4, 4, again not possible. Okay. And if I want to use 5 here, we don't have 5 here. So this case again by default is not possible. And I have to definitely use 5 because I cannot make 13 without using 5 because I'm not available with 6 and 7. So that's why it is the case which is not possible. Okay. So this case is completely ruled out. Fine. So we have to use 5, 5 and 3. That is something which I have to do. I hope you are getting the point. Perfectly alright. So S, F, C. We have 5, 5. Yes, we have 5. We have 5. That is not a problem. We have used 5 ones, 5 ones, 5 ones. We have used 3 5s. So I am left with 1 5 here. If I consider the first case, we have used 5, 5 2 times. Yes, and we have used 1 5 here. So I'll be left with only 1 5 here and 1 5 here. Okay. In this case, I have used 5 twice and 5 once. So again, I'll be left with 1 1 5 5. 1 times 5 in both this parameters S and F. So if I want to write 5, then I can write 5. I can write 5. Okay. And I have sufficient number of 3's in parameter C. So this is 3. This is possible for only one country. Why? Because if I want to make another country which is having the same score, I don't have any more 5's. Do I have 5's? 5 is already being exhausted completely. Look at this. 5 in S, 5 in S, 2 times of 5 is exhausted. 5 in S, 5 in S, 2 times of 5 is exhausted. So we don't have any more 5's to use. Okay. So how many countries can have a score of 13? 1. If B and D are having 16 and 15 scores, then other countries which are having 13 score, then only one country is possible. Okay. So see, if you have the eye for the data, you can definitely assign these frequency. Not a very complex question, but you have to have the clarity of thoughts. We have to make cases, not a calculation intensive question, more than observation based questions. Fine. So this will be it from this particular discussion. Thank you so much.